Hello everyone, welcome back to the 14th session of this Boolean Algebra lesson. Today we are going to learn all about minimization of Boolean expression, okay? So a minimized Boolean expression means less number of gates, which means simplified circuitry. Now what is the meaning of this? This I had explained in the previous sessions also, but as of now, see here, we have a expression something like this. Okay, now this is so complicated. Now if we were to draw a circuit diagram for this, we need so many AND gates, so many OR gates, so many NOT gates. But if we are able to simplify this, now the end result what we are going to get is AC. Now this just need one logic gate, isn't it? So much simplified circuit, so much less cost. Right. So that is the reason it is very important to learn how to minimize a given Boolean expression. Okay. So there are mainly two methods. One is algebraic method. The other one is using the K-map. Now K-map is very, very important from the point of view of your examination. But then today we are going to learn algebraic method. In the coming sessions, we are going to complete the K-map. Okay. So how do we do it using the algebraic method? Now this method makes use of Boolean postulates, rules, theorems to simplify the expression. So when we were learning all these postulates, rules and theorems, I had told you that in future we are going to be using them. So this is where we are going to use them all. Okay. So let's see. Now simplification is nothing but we are going to use step by step whichever rule is applicable, or we can apply them in a better way in order to make it less complicated, the given expression. So this is completely, we are going to decide. There is no proper procedure or a hard and fast rule that you have to use this rule. Okay, so depending upon, ultimately we should be getting a simplified Boolean expression, right? Fine. So simplify AB bar CD bar plus AB bar CD plus ABCD bar ABCD. So whenever you get an expression something like this, first try and see. What you can do is you can shuffle them wherever you want. Okay, you can move them and then you can try and see if there is anything common to take out. Okay, so here as you can see we have A, B bar, C common in both the terms. So I've taken it out and we are left with D bar and D. Similarly here we have A, B, C common in both. When we take it out we are left with B bar plus D. Now we know that D bar plus D is nothing but 1. Okay, so now this is where we are using the rules. Okay, so D bar plus D is nothing but 1. So what happens, we are left with this. Now when we have this, see here, again we have AC and AC common, isn't it? So when I take this out, I'm left with B bar and B, which is nothing but 1 again. So AC. Looks simple, isn't it? But if you know the rules, it is actually very simple. Next, let us move on to the next one. Now we have X, Y whole bar plus X bar plus XY. Let's see what we can do here. Now when we have X plus Y, this is nothing but De Morgan's theorem. We can write this as X bar plus Y bar, isn't it? Plus X bar plus X, Y. Now I can reshuffle and write it as X bar plus X bar plus Y bar plus XY. Now we know that any variable, same variable, x plus x is nothing but x. So this x plus x bar I can club together and then write it as x bar plus I'm left with y bar plus xy. Okay. Now let me reshuffle and write this as x bar plus xy and y bar. Okay. Now we know the distributive law, which is x plus yz is nothing but x plus y into x plus z, isn't it? Just see if we can apply this over here. So what happens if we apply it? X bar plus xy becomes x bar plus x and x bar plus y, isn't it? Now x bar plus x is nothing but 1. So 1 into x bar plus y is nothing but x bar plus y, right? So this entire expression will come down to x bar plus y bar, isn't it? Now x bar plus y plus y bar is nothing but 1, and any variable when it is ANDed with 1, we will always get 1. So the simplified expression for this particular logical expression is 1. Okay. Let's move on to the next one. Let's simplify this one. Okay. So now minimize AB plus AC whole bar AB bar C into AB plus C. Now how can we write this? We can write it as AB plus AC whole bar. Now we are using the De Morgan's theorem. So how are we going to write it? We are going to write it as A bar plus C bar, isn't it? Plus, now let me multiply this. AB bar C, AB plus AB bar C into C. So what did I do? I opened the bracket and multiplied. Okay. So what happens next? AB plus A bar plus C bar. Now this one, see here, we have B into B bar. Now this is nothing but 0. Whenever we add a complement with a variable with its complement, that is x into x bar is nothing but 0. Okay. So this entire expression will become 0. And also next expression, see here, we have CC, that is x into x is nothing but x, right? So I can write it as AB bar C, right? Next, let's see what we can do here. Now, here we have AB plus A bar. Now we saw using the distributive law, how can we write x plus y, x plus z, right? Now using that, what happens here? We will be left with A bar plus B, right? So this entire expression will be this. Then we have C bar plus AB bar C. Okay, so let me keep this A bar plus C bar here. I'll bring this B over here and let's try to apply the distributive law here. What happens? So using this same De Morgan's theorem, we can write this as B plus AC. Okay, now let's simplify this further. We have, let me bring the AC over here, plus B plus C bar. Okay, now AC will be A bar plus C. Okay, plus B plus C bar. Now C plus C bar. If I had to bring this together, A bar plus B plus C bar, this will be C plus C bar is always 1. Okay, so now if you are considering this entire thing as one variable x plus any variable plus 1 is always 1, isn't it? So I am left with A bar plus B plus 1 is nothing but 1. Okay, so this is how we simplify a given expression. Fine. So we saw already two expressions, how to simplify them, isn't it? So let's go ahead and see another example. So another example is x bar, y bar, z bar plus x bar, y, z bar plus x, y bar, z bar plus x, y, z bar. Let's simplify this. Here, this is nothing but y bar, z bar. Okay, this is y bar, z bar. Now, how do we do this? What can you see common here? I can see x bar, z bar common here. Okay, so x bar and z bar are common. Then this becomes y bar plus y. Then what do we have common here? X, y bar, z bar. So I can remove x and z bar common here. I'm left with y bar plus y, isn't it? So what happens is this becomes 1. So we are left with x bar, z bar plus x, z bar, isn't it? Now again, what do we have common here? Z bar. So when I'm doing this, x bar plus x, what happens? Z bar. So we are left with z bar. Now this is the simplified form of this given expression. So you have seen 4 examples. I hope you understood. So there is no proper procedure or you have to do in this way. Whichever you feel, okay, this can be taken out as a common or this rule I can apply, you can go ahead and do that. Okay. So that's all in today's session, students. Thank you for watching.